Today we are going to take up meaning of classification of elements, purpose of classification of elements, historical attempts of classification, Mendeleev periodic table, long form of periodic table, and periodicity in properties. The first is, what is the meaning of classification? It is grouping of elements on the basis of similarity in properties. Now we take up purpose of classification. It makes the study of 118 or more elements easier by classifying them into 18 groups and 7 periods. That is, few groups and few periods. Attempts of classification. The first attempt was made by Dobereiner, and this is called Dobereiner law of triads. According to Dobereiner, when elements of same properties, that is similar properties, are kept in the increasing order of atomic weights, the atomic weight of middle element is equal to the average or mean atomic weight of remaining two elements. Such a group of element is called Dobereiner triad. These are the examples of triad: lithium, sodium, and potassium. Atomic mass of lithium is 7, sodium is 23, potassium is 39. The average of 7 and 39 comes out to be 23, which is atomic weight of middle element sodium. Beryllium, magnesium, and calcium, the average of 8 and 40, that is atomic weights of beryllium and magnesium, comes out to be 24, which is equal to atomic weight of magnesium. Chlorine, bromine, and iodine, we add 35.5 plus 127, which are atomic weights of chlorine and iodine respectively. After dividing by 2, we get 81.25, which is nearly equal to atomic weight of bromine. So these are triads, which are also called Dobereiner triads. The limitation of Dobereiner triads: Dobereiner could arrange only a few elements as triads, and there are some such elements present in triads whose atomic weights are approximately equal. For example, iron, cobalt, nickel, ruthenium, rhodium, and palladium. Therefore, this hypothesis or classification was not acceptable for all elements. Next attempt was made by Newlands, and it is called Newland's law of octaves. As in music, the eighth note is same as the first note. So if the elements are arranged in the increasing order of atomic weights, the first element will exhibit similarity in properties with the eighth element. For example, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. Now, eighth element is sodium, which resembles with lithium. Magnesium resembles with beryllium. Aluminium resembles with boron. Silicon resembles with carbon. And phosphorus resembles with nitrogen. Sulfur resembles with oxygen. And chlorine resembles with fluorine. These 8 notes of music, 7 notes of music, sa, re, ga, ma, pa, dha, ni, sa. Sa is repeated, that is 8th note is the same as the first one. Similarly, properties of 8th element is same as the first one, or similar to the first one. Potassium resembles with sodium and calcium resembles with magnesium. It is clear from the above table that sodium is the 8th element from the lithium whose properties resemble with that of lithium. But this type of classification was limited up to 20 elements only. So the next attempt for classification was made by Lothar, and these are known as Lothar-Meyer's volume curves. The graph drawn by plotting the atomic volumes against atomic weights are known as Lothar-Meyer volume curves. These are shown in the diagrams, which you can observe carefully. It was observed that the elements with similar properties occupied similar position on the curve. For example, sodium, potassium, rubidium, cesium, francium are on the peaks because they resemble with each other. So the elements with the similar position resemble in their chemical properties. Features of Lothar-Meyer curves: the alkali metals have highest atomic volumes. Alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, etc., which are relatively little less electropositive, occupy position on the descending part of the curve. halogens and the noble gases except helium occupy position on the ascending part of the curve. Transition elements have very small volume and therefore these are present at the bottoms of the curve. Next we are taking Mendeleev's periodic law. According to Mendeleev's periodic law, the physical and chemical properties of elements are periodic function of their atomic weights. That is, properties of elements depend upon atomic weights. Now we are defining what is periodic table. Periodic table may be defined as the table which classifies all the known elements in accordance with their properties in such a way that elements with similar properties are grouped together in the same vertical column and dissimilar elements are separated from one another. Mendeleev's periodic table. Mendeleev periodic table is based on atomic weight. In the periodic table, the horizontal lines or horizontal rows are called periods and the vertical lines or vertical columns are called groups. The periodic table consists of 12 series and 9 groups. The earlier periodic table had only 8 groups. The noble gases were added later in the 0 group because these were not discovered when Mendeleev put forward his periodic table. All the groups except 8 and 0 group are divided into subgroups A and B. 2, 8, 18 and 32 are called magic numbers. This is the Mendeleev periodic table of elements. The first element shown is helium, then neon, argon, krypton, xenon. They were discovered later and put in 0 group. The first element hydrogen, lithium, sodium, potassium. Copper is also there in group 1, rubidium, silver, cesium, gold, etc. So these are various groups and periods of Mendeleev periodic table. We are going to take up merits of Mendeleev periodic table. Classification of elements then known was done for the first time and most of the elements having similar properties were kept in the same group. It encouraged research and led to the discovery of newer elements. Mendeleev had even predicted the properties of many elements not discovered at that time. This helped in discovery of these elements. For example, Mendeleev predicted the properties of the following elements: Eka boron, this was later called scandium; Eka aluminium, this was later called gallium; Eka silicon, this was later called germanium. Even Mendeleev periodic table could help in corrections of some of the atomic weights of the elements. Defects of Mendeleev periodic table. Position of hydrogen. Like alkali metals, hydrogen has 1 electron in its outermost shell or level, and like halogens, it has 1 electron less than the next inert gas. Therefore, placing hydrogen with alkali metals is equally appropriate as placing it with halogens. That is, it resembles both with alkali metals and halogens. Position of isotopes. The isotopes have different atomic weights and the periodic table is based on atomic weights. Therefore, isotopes should get different places in the periodic table on the basis of atomic weights. But actually it is not possible because isotopes have same chemical properties. And this was serious drawback of Mendeleev's periodic table. The periodic table is not fully based on increasing order of atomic weights. For example, argon 39.9 has higher atomic weight, and it precedes potassium with 39.1. Cobalt 58.9 precedes nickel 58.7. Tellurium 127.6 precedes iodine 126.9. And no justification has been provided for this ambiguity. It is not proper to place together the elements having differing properties such as coinage metal, copper, silver, gold with alkali metals, and zinc, cadmium, mercury with alkaline earth metals, and metals like manganese with halogens. Similarly, platinum and gold having similar properties have been placed in different groups, which should not have been happened. There is no indication whether the lanthanides and actinides are associated with group 3rd A or group 3rd B. The position of isobars, these elements have different groups although their atomic mass remains the same. Modern periodic law and modern periodic table. Mosley proved that the square root of frequency of X-rays which are emitted from a metal on bombarding with high velocity electrons, it's proportional to the nuclear charge of the atom. This can be represented by the following expression: nu square root is equal to A into Z minus B, where Z is nuclear charge on the atom and A and B are constants. The nuclear charge on the atom is equal to the atomic number. This shows that the properties of elements depend upon atomic number and not on atomic weight. So according to modern periodic law, the properties of elements are periodic function of their atomic numbers. That is, properties of elements depend upon atomic number. Why they depend upon atomic number? Properties of elements depend upon number of valence electrons. Valence electrons are decided by electronic configuration, and electronic configuration is decided by atomic numbers. It means properties of elements depend upon atomic number. Cause of periodicity. The cause of periodicity in properties is the repetition of similar outer electronic configuration, that is similar valence electrons or same valence electrons after certain regular interval. Now we come to modern periodic table, or it is also called long form of periodic table. One of the bases of modern periodic law, a scientist named Bohr proposed a long form of periodic table that was prepared by Rang and Warner. In the periodic table, the horizontal rows are called periods and the vertical columns are called groups. The periodic table has total of 7 periods and 18 groups. That is 7 horizontal rows called periods and 18 vertical columns called groups.